Looking at our next guest, I'm like, he has one of the coolest backgrounds ever. It's a working background.
Yes.
We're happy to bring in Bob Van Til with us here on the MegaCast. He's a professor over at Oakland University. Thank you for being with us, Professor.
Thank you. Appreciate the time, giving me a chance to talk a little bit about what we're doing here.
The work that you and your team are doing over there is so important and vital right now to help our students land those important jobs that are going to help them in their future. So, with that, you are also the chair of the Industrial and Systems Engineering Department. What exactly do you teach over there except for how to tinker with a lot of things?
Industrial systems engineering is sort of the unknown domain of engineering. It's a very old domain going back to the first industrial revolution, the founding of the steam engine, that time frame, mid 1800s. Its roots are in manufacturing design. Historically, it's called just industrial engineering, which is a marketing nightmare of a name. People hear that name and, oh boy, I'm going to be in a factory all day building stuff. And it's like, no, those are the operations people. The roots of industrial engineering are actually engineering, designing, and improving the manufacturing systems themselves. That's the root core product. Now, over time, that's expanded to a lot of other flow systems and areas like ergonomics and other areas. And so the end systems has been more of a recent append onto the name to say, hey, it's a lot more than just manufacturing. We take that very serious here at Oakland. We're one of, while a lot of schools call themselves industrial systems engineering, they only accredit in industrial engineering from ABET. We are accredited, we're one of 6 programs in the United States that are accredited in both industrial engineering and in systems engineering.
So, with that, Professor, if I can ask you as well, because we're looking at the computer monitor behind you, what has it been like for you to try to teach throughout the pandemic when it appears to me you would probably need people in person?
Well, actually engineering, that's modern engineering.
Uh huh.
Industry 4.0, digital twin, smart manufacturing, all these terms are all about going into the digital domain. So we're in the Sharp Computer Integrated Manufacturing Lab. And what you see behind me is some of the equipment you would see in a manufacturing environment, a modern environment, robots, vision systems, PLCs, et cetera. And most of the people who hands-on with that equipment out on the floor really are technicians. What engineers do is they would take all that equipment and integrate with people and processes and design the manufacturing system. And in the old days, they would do it by buying all this equipment, putting it all together. That's not what happens. You're in the digital domain now. You do all this in digital environments. And this area really, really took off with the Internet of Things. A lot of the tools you're seeing running behind me existed for a while, but getting the data to make them realistic was very difficult. And with the Internet of Things and Ethernet and networking, you can gather that data cheaply, easily, and enough to make the systems work. And so that has been when Industry 4.0 kind of took off. It was based on the fact that now you can do this on the digital domain. You can do very complex design, get very close to the final design with minimal investment of equipment and easy to make changes. I mean, it's very easy in a change to move something around in the digital way. The robot got to move 2 inches to the right because it's not quite reaching. Well, just move it over 2 inches to the right. You're done. You do that on a setup and okay, everybody shut down, get out of the cell, bring in mill rights. 2 days later, we're ready to go. And so this is where engineering is. This is the engineering. So what we do with this stuff is give our students the physical. Hey, see this stuff? This is the hands-on. You can see how this stuff works. But they do all their engineering work over here.
Wow.
In fact, what you're seeing right now is a digital twin of this system right here. And so the students will come in, they'll run this system, they'll gather information on it to understand the physical, because you need to connect those two things. You can't strictly play in this domain. You need to know, hey, it needs physical stuff. And then they run off and they do all their engineering work over there in that digital domain.
So, with that, Professor, do you believe that this has opened up because of the changes in technology, has opened up this career option to more and more people?
Industrial systems engineering has always been a great career option. Again, we launched our program in about 2005. The engineering school was back to the 1960s, but we launched our ISC program about 2005, and we've been growing pretty strong since then. All our students get jobs, most stay locally, although they go a lot of other places. But the neat thing is, a lot of different industries, again, from the systems aspect, if you have flow, you have industrial and systems engineers. And a supply chain is really a manufacturing system. Things flow through it. You go into the finance industry, data flow, decision flow, analysis. The things flowing through a system does not have to be physical. We run a senior design project almost every semester with Comerica Bank at their IT center, which is about a mile from our university. A team will work on some kind of a flow issue going on inside of that financial institution.
We're talking with Brian Van Til. He's a professor over at Oakland University and the chair for the Industrial Systems Engineering Department. And if I could just take a moment to recognize you, you've been named one of the 20 most influential academics by Smart Manufacturing magazine. That's quite the honor. Congratulations.
Thank you. We appreciate it. It's really a team effort. It's from everything we've done around here in building this program since launch. Again, we really early on went into Smart Manufacturing Digital Industry 4.0. We actually went into that predating a lot of those terms. A lot of those terms have sprung up to describe things we've been doing since, again, 2005.
So with that as well, going forward, are you teaching back in person right now?
Right now, it's up in the air on the fall. The university hasn't made the final. There will be some amount of in-person going on. The past year, it was all online, mostly synchronous online. We'd hold the classes at normally scheduled times and days and do it interactive to get more interaction with the students. Really important in engineering that you have that back-forth interaction.
So what's it been like for you as a professor over the past year? Did you like being virtual, or you want to get back to in-person?
I want to get back. I mean, I'm a hands-on person. I really like the give and take, and I try to bring that into the online to virtual environment. But engineering is about problem solving. It was just a matter of, look up the formulas, apply them, solve the problems, no big deal. But it's building the problems. The real key in engineering is understanding the problem. Once you understand the problem, the solutions are easy. It's going through that thought process to problem solve, and being live in the class where you can really get the give and take going. It really makes a difference for me. I think it's pretty critical to the higher level engineering classes.
Yeah. So with that as well, when we're talking about some of the students, where are they mostly local students, or are you teaching students from other countries as well? Because this seems like such a sought-after program.
Oakland is primarily a commuter school. I mean, 80+% of our students actually live locally and commute in, don't live on campus. And so we have a large local base. We've always had that. As we've grown, we've gotten a lot more outreach through the Midwest. We're starting to see more students coming in, but we're still primarily local. And what's interesting is our graduates, from the undergrad perspective, want to stay local. They 90+% stay in Southeast Michigan. I'll have an internship like down in Redford at Daimler. I'll have a hard time filling it because it's like, oh my gosh, all the way down. I have to drive all the way down to 696 and Telegraph Road. Do you have something closer? Our students really like to stay in Southeast Michigan. It's really interesting. Fortunately, there's a lot of opportunities here, a lot of different places. That said, I've had students go to Colorado for aerospace, the West Coast for startups, the Florida at Disney. Most Disney Imagineers are actually industrial systems engineers.
Really?
So students intern down there. They're big flow systems. You got all these people flowing through the park.
Yeah.
How do you make that efficient? People don't want to. You spend a lot of money, go down there and spend all day sitting in line. You're going to leave not real happy. They want you going through stuff, and so they want you flowing. And so the Fast Pass system, if you're familiar with that, industrial engineers at Disney came up with that system to flow people through the park more efficiently.
Wow, that is fascinating to me. And Bob, you just did briefly mention, you talked about internships. What's it been like, though, for some of the students and internships over the past year? Because we know a lot of businesses weren't even allowing their own employees into the office. So has it been a challenge for some of your students to get internships?
It's still been pretty good. Traditionally, by the time they graduate, 90+% of our students have paid internships. In engineering, you're paid. You're very well paid, no matter what level you're at. So they're always paid internships. But a surprising number, because of the digital tools and the things you can do with these tools, engineering you can do with these tools, are still doing internships virtually. Companies are using them still as recruiting efforts and getting extra work done.
Bob Van Til with us here on the MegaCast. He's a professor over at Oakland University and the chair for the Industrial Systems Engineering Department. And with that, Bob, too, how do you think the pandemic has changed your industry overall? Or has it? Will there be more opportunities for students coming out of the pandemic?
It's been strong. It went down a little bit, but it still seems pretty strong. I think those opportunities will still be there. There's a lot of interesting things going on. All the recent focus on supply chain, and the ship getting stuck in Suez, the fact that you're doing all these crazy things. A lot of that, people try to think that's because of lean, which it really isn't. In lean manufacturing, if you're familiar with that term, lean, the Toyota production system, transportation is a waste. You add value to a product by doing something a consumer wants to pay for. Me spending money to move a part from point A to point B and then charging you for it, because that's how I get my, that's the only way I can. You don't want to pay for that. I don't want to pay for your fancy conveyor to move cars around the plant. Move them on the cheap conveyor and reduce the cost of my car. That's value add. And so people are misinterpreting just in time, which is a lean concept. And these huge supply chains as being that, but they're not. Lean is about being local, buying local. Moving stuff is wasteful.
It really is a fascinating side of the world, the global supply chain that so many of us don't think about. With that, before we say goodbye, any advice you would be able to offer to maybe high school students who, if they don't know what they want to do, but they think they like engineering or they're problem solvers, any advice you'd like to offer them?
Don't be afraid of math. That's unfortunately a foundational tool that you have to have for engineering. That said, if you're really, really a hands-on person and just, the math doesn't work for me, there are technology degrees that let you get close to engineering. Career opportunities aren't quite the same, but they're very good opportunities. You will make it through the math and get it through the engetting.
Bob, when you're talking about math, though, are we talking about new math or old math?
Talking about calculus.
That at least hasn't changed, right?
Yeah, that hasn't changed. That's just a basic tools to understand what's going on, around engineering. Everything's built off that. There's just basic tools of engineering. Focus on what you want. Learn about all the different areas, and don't think that just because you've seen one mechanical, electrical, industrial engineer tell you what they do, that they all do that. You're seeing ergonomics going on in the background right now. I talked a lot about the digital twin for this system and flow. Industrial engineers, when they design manufacturing systems, people are part of the thing they design. They're not users, but they're actually embedded in the product itself. And so ergonomics, how do you do things to make sure the person doesn't injure themselves, short-term, long-term, whatever, becomes critical. And that's a whole domain. Human factors and ergonomics is one of the areas you can get in with industrial engineering. Supply chain, manufacturing, lean, quality improvement, operations management. There's all these different things you can do within the degree. And so kind of, look all across the degree as much as you can and pick wisely. We're lucky at Oakland, we have a 2-year core. You can show up here being any kind of engineer you want, mechanical, electrical, computer, industrial systems, bioengineering. And for the first 2 years, everybody kind of takes the same group of courses. And you can really investigate, see what's going on with other students, and kind of like, oh yeah, about 2 years in, you can change your major to, that's interesting. And we'll get a lot of students in industrial systems. I'd never heard of that term. Mechanical is very well known. So a lot of mechanical engineers will come in and realize, well, I'm a little more of a people person. Industrial engineering, you can be more of a people person.
So fascinating. Bob Van Til with us here. He's a professor at Oakland University, but also the chair for the Industrial and Systems Engineering Department. And Bob, again, we want to say congratulations on being recognized for the work that you do. And also, let's hope that next year your students are right there back in person.
Yeah, I hope so. I love the interactions.
Well, if you could figure out and solve the problem of the pandemic, we would all appreciate that, right? So we wish you the best of luck. And again, thank you for your time.
Thank you. Appreciate it. It was just fun.